Look at a clock. Watch the seconds move. Feels obvious, right? Time goes forward. 1 second per second, end of story. But here's the uncomfortable truth. Physics does not agree on a single universal now. And once you see why, time travel stops sounding like pure fiction. People say time travel like it's one thing. It's not. There are two totally different questions hiding inside the same phrase. 1. Can you travel to the future, meaning you experience less time than everyone else? 2. Can you travel to the past, meaning you return to an earlier point in your own history? Is basically allowed by Einstein's physics. The other is where Stephen Hawking steps in like a bouncer at the door. Einstein gives you a universe where time can stretch, slow, and split depending on motion and gravity. Hawking says even if the equations hint at time machines, nature probably forbids them. So today we're putting them head to head. Is time travel actually possible physically, not emotionally, not philosophically, physically? Let's make this concrete. Time travel, in physics, usually means something boring and powerful. Two clocks take different paths through the universe, and when they meet again, they don't match. No magic portal required. No special effects. Just different routes through space-time. And the weird part is, this isn't hypothetical. We've already measured it. In 1905, Einstein rewired time itself with special relativity. If you move fast, your clock runs slower compared to someone who stays behind. That effect is called time dilation. Not because your clock is broken, because time is not a universal river. It's part of the geometry of reality. Okay, but is it real or just math? Here's the simplest proof: particles. Some particles decay after a known lifetime, like they carry built-in timers. Muons form high in Earth's atmosphere. By ordinary everyday timing, many shouldn't survive long enough to reach the ground. But they do because from our perspective, their internal clock runs slow when they're moving near light speed. In other words, motion changes how much time things experience. This leads to the famous twin scenario. One twin stays on Earth. One twin blasts off at an extreme speed, turns around, and comes home. When they reunite, the traveling twin has experienced less time. They've effectively jumped into Earth's future. This is not a trick. It's not opinion. It's what the geometry of space-time predicts. And that's just motion. Gravity makes it even stranger. In 1915, Einstein goes further with general relativity. Gravity isn't just something that pulls, it's the shape of space-time, and that shape affects time itself. Clocks deeper in gravity tick slower than clocks higher up, so time doesn't just depend on speed, it depends on where you are in a gravitational field. That means the future is literally arriving at different rates in different places. And this is where it stops being abstract. GPA's satellites carry precise clocks. Those clocks run at different rates because they're moving fast, special relativity, they're higher in Earth's gravity, general relativity. Engineers must correct for this, or GPA's errors grow quickly. The net correction often quoted is about tens of microseconds per day. So if you've ever used maps on your phone, you've benefited from Einstein's version of time travel clocks disagreeing because space-time is real. Now the obvious question, can we do it on purpose? Yes, in principle, but the price is brutal. To leap far into the future, you need either speeds extremely close to the speed of light, or gravitational fields far stronger than Earth's, like near compact objects. Both are not exactly available at your local airport. So Einstein gives us a clear answer. Traveling to the future is physically allowed. But what about traveling to the past? To go to the past in relativity, you need more than slow time. You need a path through space-time that loops back so that forward for you returns to earlier for the outside world. Physicists have a name for these, closed timelike curves. See, basically time loops allowed by some solutions to Einstein's equations. Notice what I said, solutions on paper. not something we've ever built. There are famous examples that hint at time travel to the past, a rotating universe solution where time loops can exist, a rapidly rotating cylinder idea that usually requires extreme, unrealistic conditions. Space-time. This is where people get excited and where Hawking gets suspicious. Here's the wormhole time machine trick in plain English. If a wormhole had two openings, two mouths, and you made one mouth experience less time than the other by moving it fast or placing it near gravity, then the two mouths would be out of sync in time. Step into one mouth, exit the other, and you could emerge in what looks like the past of the outside universe. It's like having two doors that don't agree on what year it is. And it's exactly the kind of loophole Hawking wanted to shut down. Haas time travel threatens something physics quietly depends on: causality. Cause before effect. Information doesn't appear from nowhere. If you can go to the past, you invite paradoxes. What if you prevent your own existence? What if you deliver information to your past self with no original source? Even if you hate the grandfather story, there's a deeper problem. A time machine can create self-contradictory histories unless something stops it. And this is where Hawking enters with an idea that sounds like science fiction, but is actually a serious physics argument. Hawking proposed what he called the chronology protection conjecture, the idea that the laws of physics prevent macroscopic time machines from forming, not because humans are irresponsible, but because the universe might have built-in defenses against broken causality. Here's the intuition many physicists find convincing as you approach the moment a time loop would form. Quantum fields may pile up in a violent way like feedback screaming at a microphone. Instead of a stable time machine, you get an instability, a runaway effect that destroys the conditions needed to create the loop. Hawking's message is basically, sure, the math flirts with time machines, but reality might refuse to cooperate. To be clear, this isn't a finished, universally proven no. Chronology protection is a conjecture, a proposal backed by reasoning, not a final mathematical death sentence. But it's one of the strongest, physics says no, arguments we have against time machines that send you into the past. And Hawking had a dark sense of humor about it. He held a party for time travelers, then sent the invitations after the party. No one showed up. The point was simple. If time machines exist in the future, why aren't time travelers visiting us now? So what's the verdict? Time travel to the future, yes. It's not a loophole. It's a direct consequence of relativity, measured in experiments and used in technology. Time travel to the past? Einstein's equations contain mathematical paths that resemble it, but every realistic route seems to demand extreme, unstable, or unphysical conditions. And Hawking's chronology protection suggests nature blocks the final step. Einstein opened the door to a flexible universe where time can stretch. Hawking warned that the universe might still have rules that keep yesterday out of reach. If you want part 2, I'll break down the 3 most famous time machine ideas: wormholes, rotating spacetimes, and black holes, and show the exact physics wall each one hits. Subscribe to Physics Titans because the universe is always stranger than the movie version, and somehow more beautiful.